Will you be
Ye-
recording?
Yes, sir. Yes, sir. Recording is in process.
Okay, that's good. Jyoti is writing that audio sound not available. I don't know, Jyoti. I think it is available to others. So, Adhuresh, you can type a message for Jyoti. She need to check her audio settings
Sure, sure, sir.
because others may. Yes, yes.
Yeah, sir.
Are you able to hear me?
Yeah, sir.
So it means
Yes, I am able to. You are audible.
so, so it is a problem at the Jyoti end, I think then. Jyoti, please do not do any kind of these drawings.
Perhaps.
Jyoti, oh, she is writing, she is making drawings on the whiteboard, which is not desirable. Please, Adhuresh, you need to also write to her that please do not make any changes on the screen. She is making marks on the screen. Okay, so I think she will read your messages and will do the needful. Okay, so we can go ahead. And I was saying that when organizations try to take advantage of supply chain for their competitive advantage, so organizations are deciding whether they want to be on the responsive or on efficiency side. In the course, we discussed that there are multiple criteria of being responsive. It is not simply the time to deliver the products, but your ability to handle the different type of uncertainties. That is the meaning of responsiveness. Efficiency is primarily on the basis of your ability to provide products at a lower cost. The purpose of supply chain management is to maximize your supply chain surplus. And supply chain surplus is basically the benefits which you are getting and cost. Cost to incur those efforts of the supply chain. Now, to maximize the supply chain surplus, there are only two approaches. Either you will like to improve, increase the benefits, or reduce the cost. Sometimes, in a very competitive environment, you cannot change the benefits. You cannot change the price of the products because the market forces of demand and supply are determining the price of a product. So you as an individual supply chain cannot change the price of the product. So you are having very limited scope of improving the benefits. But you may focus on reducing the cost of your offering the products. And when you are focusing on reducing the cost, you are becoming a supply chain which is efficiency oriented or efficient supply chain. But sometimes it is possible to increase your benefits also. Can somebody help me to know those situations where you can increase the benefits also? Can you think of those situations where we can increase the benefits? Either you can write or
Increasing the price of the product, selling price of the product.
that I said that it is very difficult because in a very competitive market, the law of demand and supply determines the price. So if you increase the price, customers will not buy your product.
Right, right.
Maybe by actually changing the design of the supply chain
By changing
and
the design of the supply chain.
making it more effective or responsive. In that way, maybe the benefits can be increased. We can actually get benefit of the opportunity cost.
Yeah, so the answer is very close. What I think it was Chanchal. So what Chanchal is saying, Santosh, you want to say something? You are unmuted. Santosh. Okay.
No, no, sorry, sorry.
Any other input? Uday? So when you start focusing on those customers who are ready to give you higher prices, if a customer is in an emergency situation, customer is ready to pay you high price. So when I start focusing on that market segment, which is not price sensitive, which can give you customers who are those customers who are looking for immediate solutions, then obviously they are ready to pay extra premium and therefore my benefits will increase. So if I am ready to answer more uncertainties in my supply chain, if I design a supply chain targeting those customers where uncertainties are high, and because of my ability to respond to those high uncertainty customers, I will be able to increase my benefits. And that is the way to be a responsive supply chain. So when I'm increasing the benefits, I am going towards responsive supply chain. When I am reducing the cost, I am going towards efficiency supply chain. So these are two types of strategies: responsiveness and efficiency, which we discuss in our supply chain strategy spectrum. At the same time, for doing these things, for doing these things, we need to have different type of tools which we can use. And these tools are known as drivers of supply chain. Okay, before we go to these discussions of drivers, any question related to the concept of supply chain surplus and then the strategic aspects of responsiveness or efficiency. Any question? If there are no doubts, then the purpose of the session is not there. So I request that please keep asking questions, and when I respond to those questions, I think many of the points will automatically be covered. We kept this session only for this purpose, that students are having some doubts, so we should give some opportunity to interact one to one so that they can ask their questions to me.
Yes, sir.
So yes, tell any question,
So,
any doubt.
I just can you please repeat the part where you were mentioning that when we are increasing the benefits, we are going towards the responsive supply chain, and how are we when we go towards efficient supply chain, what are we doing?
Okay, so as I wrote, supply chain surplus is equals to benefits minus cost. So in a supply chain, what you are doing from here to here, it involves cost. In moving the product from supplier side to customer side. This is manufacturer, this is retailer, and this is customer. So you incur some cost in providing the product. And finally, once the product reaches in the hands of the customer, you start getting the realization. Realization means आपको पैसा मिलना शुरू होता है. If all of you can understand
The
Hindi,
payments.
yeah, payments. That is known as benefit. So these benefits are passed to each member of your supply chain. So the difference of the benefit and cost is known as supply chain surplus. We want to increase this supply chain surplus. This is the objective of any supply chain. What is the objective of a supply chain? To increase the supply chain surplus. Now this equation clearly tells that there are only two ways to increase your supply chain surplus. One is you maximize the benefit. The other is you minimize the cost. So doing everything in a very economical manner, in a very efficient manner, will help you to reduce the cost. Let me further tell you with more specific example. In a supply chain, my final price which a customer gives me is 100 rupees, and the total cost to make the product available to the customer is 60 rupees. So my supply chain surplus becomes 40 rupees per unit. Now, in order to increase the 40 to 42, मुझे 40 को 42 करना है. So either I can do 102 minus 60, or I can do 100 minus 58. Both these things are possible, na? Yes or no?
I missed you when you started from 100. Maybe there's a network issue at my end. Can you start from 100? Where you said 100 minus 60, I missed that, sir.
My point is that in a supply chain right now, the price which a customer gives for my product is 100 rupees.
Okay,
And the cost to provide that product to that customer is 60 rupees. तो मेरा जो प्रॉफिट है उस सप्लाई चेन का, it becomes 40 rupees per unit.
correct.
Now I want to increase 40 to 42 rupees. मुझको बढ़ाना है.
बराबर.
तो उसके लिए there are two approaches. Either I increase 100 to 102. 102 minus 60 is also 42. Or
Correct.
the second one is 100 minus 58. I reduce the cost. Now, making 100 to 102, this is difficult. This is possible. But how it will be possible? When I make my system, my supply chain more efficient, so that the cost becomes, in place of 60, just 58. I am reducing the cost from 60 to 58. Then only the supply chain surplus is 42. So when I start working for making 60 to 58, it is efficiency oriented supply chain, or you can simply say efficient supply chain. So generally what I do, in place of opening my stores in an expensive area, I will open my stores in a relatively low cost area, so that I can reduce my capital cost. Just 1 minute. One important call is coming. Sorry, it was director's call, so I had to attend it. So I was saying that in the first approach, the situation is slightly difficult to increase the benefit from 100 to 102 rupees. But the second approach, when we are reducing the cost from 60 to 58, this is possible. You need to do everything in a very economical manner, in a very efficient manner. So therefore, this will lead to efficiency oriented supply chains. But it is not that you cannot make 100 to 102. You can make 100 to 102 when you start targeting those customers who are ready to pay premium to you. For example, we all know Apple. Apple is targeting those customers who are ready to pay premium for their phones. On the other hand, we have so many other mobile companies which are in a very price competitive race. Apple is never in that price competitive race. Apple is always charging extra for their products. And so, if you choose your target customer in such a manner who are ready to pay some premium for your products, then you can go for 100 to 102 also. Even 105 is also possible. So both these strategies are possible. Sometimes it can be uh, you can go for increasing the responsiveness. Sometime you can go for improving the efficiency. So if we are going for responsiveness, that means we are developing a supply chain which is able to handle different type of uncertainties. You are responding to different uncertainties of the customers. Many of you must have seen the advertisements of Swiggy. Now,
Yeah, so
Swiggy,
we have seen the advertisements of Swiggy.
what have you observed in that? Tell me.
Their main USP or the main capturing point is that it will be delivered within 25 minutes or within 20 minutes, something like that.
वो तो
Within
डोमिनोज भी
minimum,
करता था। वो तो डोमिनोज पिज्जा भी करता था, बहुत समय से कर रहा था। 30 मिनट्स में नहीं देंगे तो फिर पैसे भी नहीं लेंगे।
but they are adding discount also in that 30% discount, 20% discount.
स्विगी
Swiggy in some cases they are giving
नहीं
discount
नहीं,
as
और
well.
स्विगी और कोई दूसरा आदमी कुछ बताए इसके बारे में। You are correct, but there is something more which I want to discuss here.
So they want to be responsive. They want to satisfy the customer because whenever we order food from Zomato or Swiggy, so we want to get it uh, earlier as possible. So they try to target those customers who are willing to pay higher
Higher for?
for the product, for their product, for the product, for the delivery of their product.
No, but you see, as a customer, why will you
Yes.
pay higher when you are not getting any special service? So what
Sir,
is that special service which Swiggy is providing?
so customized packaging.
No, I think you have not seen the advertisements which I am talking. Maybe when you see these Swiggy advertisements these days, in many of their advertisements, they highlight delivering single rasgulla, delivering only single rasgulla. So Swiggy is showing their ability to deliver from one item to Sagar. You can mute yourself. Sagar, you can mute yourself. Yes, thank you. So they can deliver from one item to 50 items. So they are able to handle the uncertainty of the quantity. If you are a single person and you order a single samosa, a single rasgulla, a single cold drink, Swiggy is ready to deliver that also. And if you want to do a small party of our NPTL class, and for that we require 20 samosa, the Swiggy is ready to deliver 20 samosa also. So that type
There
of,
is no MOQ as such.
pardon?
What they are targeting is they are not keeping a MOQ, a minimum order
Yes,
of
so they
quantity.
are, if they are not keeping any MOQ, that means they are able to handle that uncertainty of order quantity. And therefore, they can charge some premium. Though that Rasgulla, if you go to the market, if you purchase from the shop, may cost you 20 rupees or 25 rupees. But when you order from Swiggy a single Rasgulla, it may cost you 40 rupees. But then you see, okay, I'm getting the benefit of getting this Rasgulla at my home environment. So you are ready to pay that 40 rupees. So for those customers who are not that price sensitive, Swiggy is providing these kind of additional benefits. But if I generally, if you see in your local markets, custom shopkeepers or the delivery systems, they have some minimum order quantities, MOQs. That if your order is 200 rupees or 500 rupees, then only we will give delivery. So that means you are not responsive. You are more efficiency driven. So that's how you can understand this concept of efficiency and responsiveness. I hope we understood this point now.
Yes, sir, understood.
The other important issue which can be worth discussing, the concept of push and pull in a supply chain. Push pull concept means in a supply chain, either you are pushing the products to the market or customer is pulling the products. When we are pushing the products into the market, it means you are working in anticipation. You are proactive. You are anticipating that there will be a demand. And in that anticipation, you will be producing the products, you will be keeping the stock, and whenever customer will come, you will immediately serve those products. Suraj is saying, can we get recordings of this session? So yes, we are already doing the recording, Suraj, and once the session will be over, we can share this recording with all of you. So push means in anticipation, and pull means that customer demand comes first, and once the demand is there, then we are producing the products in response of the customer demand. So pull system becomes reactive. Push is proactive in anticipation. So generally in pull system, we do not keep inventories because you make the product only after the order has come, only after the demand is there. So you are not doing anything proactively, you are not anticipating anything. While In the push system, you are anticipating and you are feeling that customers are going to come, they will buy the product, so I should keep these products readily available with me. So that is the difference between push and pull. Now, no supply chain is completely push, no supply chain is completely pull. If this is a supply chain, in this supply chain, there will be few stages which are under push and there will be few stages under pull. So as a top management, as a supply chain CEO of the company, you need to continuously think that how many stages are under. So this can be the push and this can be the pull. In some other supply chain, you can keep 3 stages under push and 2 stages under pull. So different type of supply chains will have different boundary of push and pull. And this becomes a major decision point for any supply chain manager, that how many stages are under push and how many stages are under pull systems. But understanding push and pull is very important for good supply chains. Generally, let me tell you that for products with low unit value, products like FMCGs are under push category, and products which are slow moving, products where unit value is high, consumer durables, these type of products are more under the pull systems. So with the examples, you will be able to understand that how much of this supply chain will be under push and how much of this supply chain will be under pull. So this gives you the basic concept of push and pull. But finally, it will also depend on the nature of supply chain partners. If a partner is generally, you can understand, you will have more risk, more capital involved in case of push, because you have to always keep inventories. So you will incur the cost. That is the challenge with respect to push. Pull, you are gathering the orders, demand, and then you start making the product. Then you think of how to provide the product to the customer. So the risk is relatively much less in case of pull. So whether your partners are ready to take risk or not ready to take risk, it also becomes a very important criteria to decide a suitable push-pull boundary in your supply chain. But every supply chain has some element of push and some elements of pull. It is at the top management that how much of those stages are under push and how many stages are under pull. This is another very important thing which I think you all should know. So any question, doubt with respect to push pull?
Right, sir. I just had a small doubt. According to the schematic that you have shared, uh, uh, is there any case wherein the pull is at the start and push is at the end? Because sometimes we might procure raw material in anticipation of orders, and then we are keeping inventory, and then the order comes, and then it goes into pull at the product stage. But is it possible that the raw material is in the pull stage and then the final product is in push stage? Is that possible?
You see, theoretically, it may not be possible, because as you are moving from left to right, you are adding value.
Correct, sir.
Now, as I already mentioned, in the push stages, you are maintaining the inventory. Now, when the value is added, more value is added, the cost of the product becomes high. So, keeping the inventory of high cost activities or high cost product is not desirable. If you are keeping the inventory of, let's say, finished jewelry in a jewelry shop and keeping the inventory of simply the gold biscuits. So, since the cost of the gold biscuit is much less as compared to jewelry, so you can keep gold biscuits in anticipation that there will be a demand of jewelry in near future. But you will not keep the jewelry readily available in your stocks because it will increase your holding cost dramatically and it will make the supply chain unsustainable kind of a thing. So that is the reason you will have push in the upstream area and pull in the downstream area.
Sir, I have a question with
Yes, please.
respect to the high value of the products. Like we are saying that the pull kind of strategy is used when the product is normally of a low value.
No, no, pull is used when the product is high value.
Okay. So I have an example of like the expensive cars that is actually produced on demand.
Yeah, so that is all pull.
These are all pull strategy, right?
Yes, yes.
Yeah. Okay.
Expensive cars, designer jewelry,
Yeah.
designer dresses, all the expensive items, you will see that are available on pull only. So if a real estate company is making a new colony, new society, so in a building, flats can be made on a push system, but the villas will be made as a pull concept because villas are having more unit value as compared to the flats. So those customers who are looking for ready to move solution, they will like to go for that apartments, and for them push system is going to work. But if I want something very specific to my requirements, I am ready to wait also, because in pull system what happens, it is only possible in those products where customer is ready to wait because the product is not available immediately off the shelf. So you also need to see, if I keep you go to a restaurant, all of you must have visited any kind of restaurant. So when you go to a restaurant, generally restaurant may take 15 minutes, 20 minutes, 30 minutes to serve your order. That is an example of last minute pull activity. Uday loves vegetarian food and Abhinay loves non-vegetarian food. You both are going to the same restaurant. You are friends. Now, Uday has ordered butter paneer or shahi paneer. Abhinay has ordered chicken. So the kitchen has raw materials available, semi-processed raw materials available. Now the same curry will be used for making the shahi paneer and the same curry will be used for making the chicken also. So final preparation of the dish is under pull system, but that restaurant is keeping the inventory readily available of all different types of dishes which it is serving, because restaurant knows there are customers going to come for paneer also, there are customers going to come for chicken also, and accordingly as the order comes they will prepare the final dish. So the final delivery is under the pull. Now if restaurant says that we want to more pull, so once the order is placed, then the restaurant goes for purchasing the chicken. Then the restaurant goes for purchasing the paneer, cheese. It will take 2 hours to serve your order. And you all know that you are not ready to wait for 2 hours to get your order served. So there is last activity, last final preparation of the dish that is under pull, and rest of the supply chain is under push. In some other cases, you may have more stages under pull and less stages under push. So how many stages are under push and how many under pull? That is always a very debatable matter, and top management of the company takes continuous decision about this particular aspect. Neelam, are you driving? Neelam? Yes, Arvinda,
Yes, sir.
you have any question?
I actually wanted to have, some questions, practice questions for week 7. That is what demand uncertainty, optimization of demand, optimization of price. So that I am looking for because that needs a lot of practice. I was a bit of
Okay,
confused
okay,
in,
okay, okay.
yeah.
Actually, I wanted to keep two such doubt clearing sessions
Mhm.
because in one session it may not be possible to answer all the queries. Like
Yes, yes.
Uday has mentioned in the chat window, I have doubts in the numericals. So kindly
Mhm.
solve assignments of week 4 and week 6. So yes,
Mhm.
now for that I have to first open the assignments of week 4 and week 6. Since
Mhm.
we were not having the specific questions before coming for this doubt session, so
Yes,
I will
yes.
request uh, we may have another doubt session also. And
Okay.
Certainly,
before
sir.
that, before that, you need to give all these specific queries that you need, how to solve the assignments of a particular week or a particular question, so that
Mhm.
we are ready with all the material, and we will not go for any kind of preface. We will directly go
Okay.
into the solution mode of those specific assignment questions.
Mhm.
So
Right, sir. Right.
yeah, so we may do one more similar kind of a doubt clearing session. Since I was not having any question beforehand, so I thought let me start with a broad overview of the entire syllabus. But I will love that if we can use our time more effectively by answering the specific questions of our students.
Yes.
Sir,
Right, sir.
Yeah, Adhuresh has opened.
yes, sir, yes,
Adhuresh.
sir. So may I pitch in?
Yeah, yeah, please.
So, dear learners, actually, week 7, the solution will be uploaded post the deadline for completing that assignment. That is tomorrow. And today we have today we have posted the solution Excel file for week 6. So please go through it. I think you will find the solution, the in fact the solver and everything we have given. So you can find the solutions there. In case of any a doubt still remains, please let us know. We will be handling that. Yes, sir.
Perfect. Thank you.
Thank you, sir.
Hmm. Suraj, any question?
Hello, sir. Good evening.
Yes, Suraj.
Sir, before I'll pitch in, I do not have any specific doubt in this particular course, but I'm more interested to know about that the analytics part of the course, because whatever I have learned or whatever the video I have gone through, I believe that is a hardcore supply chain. So basically, very tactical things of the supply chain. So I was looking for something related to the analytics part of the supply chain. I mean, how I can use analytics.
Okay.
So is there any other course by you so that I can audit that course or I can attend that course, sir?
No, there are some courses which I am offering, but
Hmm.
mm, these courses are not available through NPTL. These are available through private edtech companies. So
Okay.
their fees are slightly higher than these NPTEL courses.
Okay.
So I will not like to market my
Mm-hmm.
courses in that way in this platform. So
Mm-hmm.
it is up to you that whether you want to join them or not.
Mm-hmm.
But yes, this course, when we developed, we focused more on the supply chain side of the
Mm-hmm.
course. Though we have discussed certain analytical tools in this course, but there are many more things. There are many more things which can also be included to
Mm-hmm.
make the analytic component even more stronger in the area of supply chain. There is a scope for that. I
Oh,
agree.
yes. So actually, that was the reason I joined this particular course because I did my MBA from known college of supply chain in Mumbai,
Yeah.
and that is a primary reason I wanted to revisit my concepts and get more perspective on the analytics part of the supply chain. So
Hmm.
anyway, I will check in the websites.
Yeah, you can.
What are the courses available by you through the
Yes.
paid channels?
Hmm.
Thank you, sir. It is really privilege to be taught by you.
Thank you very much.
Thank you, sir.
Another important thing which I think
Uh, so to
Sir,
ask a very trivial question again.
no, no,
So,
no.
sir, this is a 8 week course, and there are few weeks which I need to complete. So, how long the course will be available to my user ID?
That is a NPTEL policy. Even I am not having a right answer at the moment that how far the course will be available to you after completing the course. So I will like to answer this question after consulting the our NPTEL office.
Okay.
So, or if Adhuresh has a ready answer for this question, Adhuresh, can you help Suraj to answer this question?
No, no, sir. That is something that I also am not aware of.
Okay.
I
That
can I can check with the team. I can let you know. Please drop an email to the email ID. We will definitely get it resolved.
Sure.
Because
Sure.
you see, let me tell you one thing.
Hmm.
The all course videos are always available through YouTube. So
Hmm.
those course videos are in any way, even if you are part of this course or you are not part of this course, you can still access those course videos. All 40 videos are available on the YouTube. The only
Hmm.
thing is these assignments and other discussions, how long it will be available to you, that is a matter of concern. So I think even I don't have answer to this
मैं
question.
एक बार NPTEL admin को एक बार mail लिख करके I'll get the answers. So
हाँ, you can बिल्कुल बिल्कुल you can do that, and we will also like to check from our local NPTEL office at
sure,
Roorkee.
sir.
Rajat sir, I have a question. Actually, I have some doubt in the question itself. That in a question where optimal quantity is required to be calculated, there is a question wherein some scrap handling cost is there. So whether
Yeah,
that cost is per unit cost or is it a compounded cost of whole of the scrap?
It is
no, no,
per unit.
it is per unit cost which is given in that question.
Okay, okay, okay. So that was not specified. Anyway, I solved it with the unit per unit price also.
It is per unit.
Okay, okay. Thank you, sir.
Good evening, sir.
Yes.
Sir, I am facing problem while attempting question. I didn't get any specific approach. When I see your videos, I can learn. But when I apply them to assignment question, I didn't get answer or solve the question properly. So kindly
Okay.
guide.
Hmm. You see, even if you start solving the weekly assignment problems, I think you can still solve those problems because you know that the assignment is related to the concepts which we have discussed in that particular week. The bigger problem will come when even the assignment, the weekly content is not available, and you should be solving a problem without knowing what is the background, what is the context of this particular problem. You see, in any supply chain problem, there are three, four very important. Okay, there are people who are writing on the chat. Jyoti is saying that please clear doubts about mathematical problem. Week 7 assessment due date is tomorrow. Abhishek is writing, I sent several regarding the week 10 assignments several times, but I have not received. Week 10 assignments, Abhishek, I think our course is of week 8. So, Abhishek, I don't know how week 10 assignments you are mentioning. Adresh, what about this week 10 assignment which Abhishek is writing?
I think, sir, he meant something else. I'm not sure what it is because the course is of only 8 weeks. So, uh, Abhishek, Jake, please, can you unmute yourself and ask?
Adresh,
Yes, sir.
there are many students who are looking for some kind of help with respect to week 6 as well as week 7. I
Yes,
think
sir.
week 7 assignment we cannot discuss today because the deadline is yet not completed,
Yes, sir. Yes, sir. Yes, sir.
I think. But you may be having the solution and questions of week 6 assignment.
Yes, sir. Yes, sir. I do have.
Yeah. So since many learners are interested to know the solution process of week 6, can I request you to take it now and complete or you can demonstrate them how to solve the week 6 assignment questions?
Sure, sure, sir. Sure, sir.
Since we have booked this session up to 8 p.m. and we
Yes,
still have around 45
1 hour.
50 minutes, but before that, since we are already in this session since last 1 hour, we can have a quick break of 7 minutes, and then these learners can, because the link will remain open, no problem. You can have a quick break of 7 minutes, and then Adhuresh will take problems of week 6 assignment, and you can get the solutions, the process.
Sure, sir. That would be great.
Yeah. So, okay.
Okay, okay, sir. Thank you.
It is 7:05 and we'll start at 7:12.
Sure, sir.
So, Dhanush, I have to stop share, na?
Yes, sir. Yes, sir. Please stop screen sharing. I'll share my screen.
Right, right, right. Okay.
Okay. Thank you.
అంటే లేదండి వెళ్తా నేను లేదా వెళ్తా ఆల్రెడీ మీటింగ్ ఒకటి స్టార్ట్ అయింది అందుకని అప్పటి నుంచి ఫోనే పట్టుకోను మీరు ఆన్సర్ చేస్తారా లేదు
Good evening, sir.
Good evening, everyone. Am I audible?
Yes, sir. Yes, sir. You are audible.
Yes,
Okay.
clearly
Sir,
audible.
sir, actually, I have a question.
Yes.
That type of questions will come in exam which needs solvers like
Yes,
transportation
solver.
problem.
Yes, actually, solver is an integral part of supply chain optimization, network optimization problems. So
Okay.
you can expect a question from solver, though the questions will be similar to what has been already asked in assessment or what has been taught in the course. So
That means we will get solver options, na?
yes, yes. You can open your excellent solver. Like I'll just check with sir because I'm still not aware of the nature of the questions and whether like it will be a open book kind of question. So in that case, if that is there, then you'll definitely get access to solver as well. Now I'm about to start, but before that, since I'm handling both the chat as well as the audio, it would be better if you can ask your queries through audio, like unmuting yourself. And
Sir, I have one more question. That
yes.
in week 7, the second lecture having uncertainty in network design, and week 6
కలుస్తారు కూడా అండి
this is the
వస్తాడు ఆయన
lecture
వేరే వాళ్ళు
time
అన్నారు
value of money. It is repeated content.
Uh, so actually, in both of the problems, we use the same similar concept. So that is why that video is there, and it will help you go through the next step. That is why it is added. Though it is something that is there in the structure of the course, so we can't change it. But I think that is not exact repetition. The video is slightly different.
Sir, and in the week 7, first lecture in optimal level of product availability and supply chain, I think the lecture is cut between.
Is
I
my
think it is
screen
not
visible?
complete. Yes,
Is
sir.
my screen visible? Is it the
Yes, sir.
same
Yes.
session that you're talking about?
Sir,
Yes, sir. Yes, sir. I think this video is not complete totally.
Okay.
Or after that, everything.
Okay.
Because the
Are you
particular question
hmm?
because the particular question Rajesh sir was discussing is not completed in the next lecture or in it in
Yes, sir.
the particular.
Okay. I think like since actually as by the wording of the sir has used, I think it is complete lecture. But don't worry, I'll look into it. And if any part of it is missing, I'll definitely talk to the team, NPTL team, because actually there is a long process of things to do here. So we have to go back to NPTL team and check whether they have some recording that is not uploaded. Maybe what you're saying, the time value of money is repeated, so they might have like put repetitive content. I'll definitely check it and will get back to you on it. Okay.
sir, kindly start with week 4. I have many doubts in it.
Week 4 actually. So first, let me give you a brief introduction of mine. I'm Adharesh Pandey. I'm a research scholar under Professor Rajat Agrawal sir, at IIT Roorkee, and I'm working in the area of supply chain only. So week 4 ka actually I'll have to just just a second. So today, like I thought that most of the questions will be from week 6 because that is a bit tricky part. Week 4 we can also cover, but I think it would be better if we can schedule some other session for that.
I think that is
And
a good
today,
idea. Let's complete week 6, then go to week 4. Whatever you have
then we
prepared
can go
for.
to definitely. So we can
Sir,
do
how
the
can
week
we
4 again.
schedule that?
You don't need to worry about that. I'll get it scheduled this week, I guess. Okay. Okay, then I'm sharing the Excel file. So as we have made the solution of the problems, and mm, mm. So yes, so these are the major
అంటే
questions where you
చదువుతాను
yes.
అంత లేదండి లేట్ అవుతుంది లేట్ అవుతుంది కానీ మళ్ళీ నేను ఇంకా వేరే పని
Please mute yourself. Others, please mute yourself.
Okay.
వద్దండి ఆల్రెడీ నేను నిన్నే వచ్చిన తీసుకొచ్చిన
Okay. Now, before going directly to the question, let me tell you a few things about network optimization problems in general. So, we will first talk about what is constraint optimization. Constraint optimization. So, the thing is that whenever you get any problem where there are some constraints, there are some things that are under your control, and you have to uh, get the maximum benefit out of that situation. For example, let's say you have 100 rupees and you are going to a stationery shop. Okay, now you can buy pen, paper, pencil, geometry box, whatever you want to. But the thing is that most like you must have prepared a list of all the necessary items that you want in your life, want from that stationery shop, right? So what is your agenda while going to that stationery shop? Can anyone please give any idea or give any explanation? Why do you go to that stationery shop, and what is your objective of going to that stationery shop basically?
The objective will be to procure stationery instruments, rulers, scale, pens,
Objective
pencil,
would be to procure
to buy and to procure
your stationery. Okay.
stationery
Uh,
items.
okay. Now, in other
Uh,
words, yes, please.
yeah, actually, it is first thing that I should get all the things that is required by me. Number one. Number
Uh-huh.
two is this, that I should be able to get that all the things within my budget. That is
Budget.
whatever the budget I have set in my mind, just like
Right.
100 rupees. So
Right.
that should be accomplished.
Yes. So now the thing is that, in other words, can we call it to maximize the value, to maximize the value out of 100 rupees, right? You want to maximize the value that you get from that 100 rupees, right? Would it be okay to say that?
Right.
Yes.
Right.
Okay.
Yes,
So
yes.
now your objective is to maximize the value that you are getting from stationery shop. Nice. What is under your control? What are the decisions that you have to make?
Whether to buy or not to buy.
Decision variable. So you're saying whether to buy or not. Okay.
Basically, those has to be come within whatever money I have.
Yes. So basically whether to buy or not and how much to buy, right? How much to buy? You can buy one pen, you can buy many pen, right? How much to buy? So basically, what all options you have, that is what you have to decide upon, right? Like you can buy a pen, as I already said, right? So that is your decision variable, like the decision, the options that are in front of you, and the decision that you have to make, that will be your decision variable. For example, I have to buy four things, okay, and it can be again like a geometry box, okay, a pencil, a notepad, uh, let's say uh,
Ruler.
sharpener, ruler, whatever it is. Okay. Now, out of those things, you have to buy four, only four, and let's say you have to buy four things out of all these. Now, what is your decision variable? What are your decision variables here? Whether to buy a geometry box or not, whether to buy a pencil or not, right? Whether to buy a notepad or not, or and on, right? And how much to buy? Please let me know if you are able to follow me. May I ask someone to keep yourself on unmute and respond to my queries?
Yes, sir.
Preferably someone who claims that he does not have an idea of network optimization.
Then that would be
Uday, because Uday asked this
Yes.
question. Okay, please keep on unmute so that we can discuss it out. So now we have two things. First was your objective function. Second is your decision variable. Now, what is your constraint? Like, what are your constraints here in this problem? You have 100 rupees. You are going to buy something from a stationery. So, what
A
is your constraint?
100 rupees and
Yes.
buying optimal things.
So 100 rupees is your constraint. Let me just write here constraint. So one constraint is that you only have 100 rupees. Second, we just have added an artificial constraint that we have to buy four items only. We cannot buy more than that. Okay, so these are your constraints. Now, any problem in your life, you can think of all these three things. Like, and there will be an objective function. There will be some decision variables. Like, for example, if I want to maximize my score in the NPTEL final exam, so like there will be objective to maximize my score. The decision variables would be how much time should I study, okay, and constraint will be the amount of time that is left or the reading material or study material that I have, right? Similarly, when we talk in context of supply chain, uh, there are two chats. What all items we should buy? Yeah, Nidhi is writing. Great. maximum things available at shop. Okay. So in any problem, actually we call it linear programming. I'm not going into technical terms so that it might confuse you. But in terms of supply chain, whenever you see a problem, try to find the decision variable, the objective function, and the constraints. If you have identified these three things properly, okay, then it is a job of a solver, MS Excel solver, or any other tool to give you the solution. You don't have to solve it by hands, right? So the idea of modeling is to identify these things in three things in a problem. Now, with this brief, let me go to the question that we have. I hope this screen is visible. Is it?
Yes, sir. It is visible.
Okay, great. So let me read out the question. A company has three plants, plant 1, 2, 3, and 4 distribution centers, DC 1, 2, 3, 4. The shipping cost per shipment in dollar from each plant to each distribution center is given in the below following table. So what is this? This matrix?
Shipping cost.
Shipping cost
Shipping
per
cost.
unit. Per unit. So if I ask you, like, I'm transferring 1 unit from plant 2 to DC2, it will cost me 12 rupees.
12
12
rupees.
rupees or $12, whatever it is. Okay. Now, on the right hand, you can see the supply capacity of these plants, right? Similarly,
Yes, sir.
there will be 4 each distribution center will be having its own demand. So there will be 4 demands that is given over here, right? Now, if I ask you, just don't focus on all these things. If I ask you, what is your decision variable in this problem?
Mm, How much to
How
supply?
much to be supplied to each?
How much to supply?
So from plant 1 to distribution center 1, 2, 3, 4. So basically, the cells that are given in green are basically your decision variables, right? Initially, let me put everything to 0 so that there is no confusion. Okay. So that we'll be solving this problem from scratch. So this is your decision variable. How much to supply? Somehow this pen is not working. Mm, okay. So for this problem, I'm just writing my everything here. So how much to supply? Okay. What is your objective in this problem?
The total cost should be minimum.
The total cost
Total
should be
cost.
minimum. To minimize the total transportation cost. Now let's talk about constraints. So what constraints can you see in this problem?
Supply capacity, demand capacity.
Supply and demand capacity.
Okay, so supply capacity and demand capacity. How will you interpret it? Okay, like if 60 is written over here, so what does it mean?
Supply capacity.
From 4 capacity, each capacity can maximum transport 15 units.
No, not 15 units.
Sir, it is
Supply is not
constraint
greater than not equal
plant
to supply
1.
capacity.
Yes. So whatever quantity is going, which means, okay. mm, uh, So sum of all these 4 units, right, cannot be more than 60 units,
Yes.
right?
Yes.
This is what is this? This is your quantity matrix, which shows that या प्लांट 1 पे यहाँ DC1 पे कितना जाएगा, DC2 पे कितना जाएगा, DC3 and DC4 पे कितना जाएगा, right?
Right.
So the sum of all these cannot be more than 60.
Yes.
This is the basic idea. So here in this cell, I hope basic Excel you all know. So in this cell, I have written sum of C16 to F16.
Right.
This file is there with you, so you can see the formulas later as well. So here I have written sum of C16 to F16. Similarly, here it is C17 to F17 and so on, right? So the constraint will be, so I have written all the constraints here. The plants cannot supply more than their capacity. It means that G16 to G18 should be less than or equal to G5 to G7. G16 to G18 should be less than or equal to G5 to G7. I hope this much is clear.
Okay.
Okay. Now, again, what about demand capacity? Can anyone tell me, like, how should I interpret it? Demand actually, sorry, this is not the right way to write it. It is just demand. It is not capacity. Demand at these locations. So what about demand? How would you interpret these numbers?
The
That
demand
is
from the
the
market.
maximum demand from the market,
This is
maximum
the
it can
price.
accommodate.
No. If
The
you
total demand of
So DC will take only this much amount of quantity, and we cannot supply more than the demand.
no.
so this
The
is
demand,
the DC1
the demand
total
has to be
demand.
met.
Okay. Let me tell you one thing. If I put what you're saying, what you're interpreting is like
This is the total
almost,
requirement of DC.
it is almost right. But let me tell you one thing. If I say that DC cannot absorb more than 45,
Yes.
it means that I am telling to my model that you have to supply less than 45 to DC1. Okay. Hello.
Yes.
In that
So
case,
can you please repeat?
okay. Actually, everyone is saying that these numbers mean that a DC1 cannot have more than 45 units, right? What
Right.
I'm saying is that if you put this thing in the model, what it will do? Can anyone just give me a minute, just a sec. Hello.
Yes, sir.
Hello. So now, if I put that, then my model will say that don't supply anything to DC, because it will then the total cost of the network will be zero, right? Because you have put your objective function such that the total cost should be minimum, right? Some product of this, this, and this. Am I making any sense?
Yes, sir.
Yes.
Okay. So I hope you understand the idea. If I put that sum of all these three, just a second, sum of all these three should be less than 45. Here also we have put that sum of all these three should be less than 60. Right? It means that it can be 0, 0, 0, 0, right? In every cell, if you don't supply anything from any plant to any distribution center, the total cost of the network will come out to be zero. But no, actually we are there in market to do business. We want to cater to this demand. The idea is not to minimize the total transportation cost. The idea is to fulfill that demand. right? If you're not fulfilling that demand, there's no point of you doing that business.
Right.
Uh-huh.
Right.
So here the idea will be the like equation will be such that sum of all these three should be greater than or equal to 45. At
Okay.
least we should be able to supply at least the demanded quantity. We can supply more than that as well, but at least we should supply the quantity that has been demanded. Okay. Now, so for that, like I'll be talking about how we put everything in the solver. That I
Hello.
will talk. Hello. Yes.
Yeah, sir, I am sorry to interrupt, but I understood that you have said C5, summation of C5 to C7 should be greater than or equal to 45. Can you please explain it again?
No, I said that summation of C16 to C18
C16 to 17, right?
should be greater than or equal to 45.
Yeah, I did not get that point.
Okay. Again, let me just repeat it. Uh, if you're putting that your total supply to DC1 should be less than 45, and your objective is to minimize the cost, what will your model do? Tell me.
I'll make sure that less number of distribution is not done of units, so that because if less is done, the cost will be high.
No. Here we are not talking about economies of scale. That is some other thing. Uh,
Okay.
yeah, the basic question here is that if you are saying that the demand, like the sum of supply to DC1 should be less than 45. Just focus on this point. Should be less than 45. What will your model do? It will put 0 in all these places, right?
Right,
Because it
right,
has to
right.
minimize the cost. Because even if, let's say, I'm just putting one here, okay, putting one will add 8 rupees because 8 is the cost of this route.
Okay, okay.
Okay, so if you are saying that you have to minimize the cost and your demand, your supply to DC1 should be less than 45, then what your model will do? It will put 0 everywhere,
Right,
so that nothing is supplied and there is a total cost comes out to be 0. So
right.
in terms of supply chain network, we we don't take demand as something that can be fulfilled or cannot be fulfilled. We will talk about demand in the sense that if 45 units are have been asked for, this much should be fulfilled. Okay.
Okay, okay,
So that is why I put here that sum of all these three should be greater than or equal to 45.
okay.
Okay. So how I put greater than or equal to 45, that part will come later. For now, we have just written here sum of C16 to C18. Similarly, sum of D16 to D18 and so on. Okay, great. Now I've talked about constraints. Plants cannot supply more than their capacity. Demand for every distribution center should be fulfilled. Okay, so for that we have written this. So it means that C19 to F19 should be greater than or equal to C8 to F8. Okay, that thing is there. Now putting all the values into the solver, we will get the transportation cost to be $1,000 per dollar. I'm sure that most of you might not be aware of how to enable solver, how to use solver. So let me just quickly give you a brief. I want everyone to, like, if possible, open your Excel workbooks. If not, then please follow this with utmost sincerity. Now, how to invoke solver in Excel? You need to go to File, go to Options by clicking on More. Here in Add-ins, if you click on Go at the bottom, there will be many tools that are available. So on that, click on Solver Add-in. Okay, check the box, click OK. And when you go to Data, on the right ribbon, you will find Solver. Everyone able to follow it?
Yes, sir.
No, sir. After data.
When you click on data, you'll find solver here. Solver, can you see my screen, my cursor?
Yeah. Okay.
Okay, now click on solver. I'll just reset everything so that we can do it from scratch. Now, what we talked about in any any optimization problem, what three things were there? Can anyone please tell me?
Decision variable, objective function, and constraint.
Constraint. So set objective. This like space is talking about setting your objective cell. So in this, we have put our objective cell in this like objective in this cell B23. So we'll be clicking on it. Okay. What we have put in B23, I think I forgot to tell you. Sorry. So we have put some product of C5 to F7 and C16 to F18. What this function will do, formula will do, is that it will take each and every value. So 8 multiplied by this plus 6 multiplied by this plus 10 multiplied by this plus 9 multiplied by this plus 9 multiplied by this plus 12 multiplied by this and so on. Okay. Hello.
Okay, so C5 into C16, D5 into D16, and so on.
Yes.
And for the next row as well, C6
Yeah,
into D17.
Okay.
Okay.
So this
So
is
that
for
is the
this
maximum
formula.
value.
No, that is just the sum product of these two functions. So for example, let me just tell you. Let's say I have written 2, 3, 4, 5, 6, 7. Okay, and in other cell I have a similar dimension ka cell. We have 12, 13, 45, 56, 78, 97. Okay, we have these two matrices. Now I want 2 into 12 plus 3 into 23 plus 4 into 45 plus 5 into 56 plus 6 into 78 plus 7 into 97. In order to get it, we write this formula. We use this formula, sum product of this matrix, comma, this. And this will give me the solution. Okay.
Okay.
Okay, nice. So similarly, here we wanted these things, right? If let's say if I put 6 here, so 6 units are supplied. Okay, each unit costs 8 rupees. It means that total cost of this route from plant 1 to DC1 would be how much? Okay. Why is there so much silence? Hello?
Sir, can you please repeat your question?
What I'm asking is that if we are supplying 6 units from plant 1 to DC1, okay, and supplying 1 unit from plant 1 to DC1 costs you 8 rupees, how
So
much
the
it will
cost will
cost?
be 8 into 6, 48.
48, right? Okay. In this cost, if I add that we are supplying 5 units from plant 1 to DC2 and 1 unit costs 6.
30.
So it will, right? So 48 plus 30, right? And it goes on and on, like it can go on and on. Okay, so this is what we need. The total cost would be how much? 8 multiplied by 6 plus 6 multiplied by 5 plus 10 multiplied by whatever is there plus 9 multiplied by whatever is there, right?
Right, sir.
So whatever is there in these green cells, this thing will come when we will use solver. Okay, right now everything we have put to 0. So that is why our total cost comes out to be 0. But when we will use solver, when we will be done making this model and solving it, there will be some values coming over here, coming in these cells. So that will give us the amount that needs to be transported from each plant to each distribution center. That is the idea behind the entire activity. We want to get how many units to supply from each plant to each distribution center. Okay.
Okay,
Hello.
sir.
Okay. So now these are my decision variables. Initially we put everything to 0. This is my objective function. My constraints, I will be directly putting it into solver. Again, let me invoke solver, and let me try to put everything in. Now, objective function. Where is your objective cell? Your objective is to minimize the cost, right?
B23.
B23. So this is your total cost ka cell. So this is your objective cell. What is your agenda? To maximize, to minimize, to set it up on a particular value.
Minimize.
To minimize. Great. Now, by changing variable cells, so here you need to put decision variables. Which cells can be changed, can be varied. What cells can be changed, varied. Okay, so what cells are there?
The green highlighted one.
Green highlighted one. So we will just select these. Okay, we have selected C16 to F18, right?
Yes.
Okay, please follow this cautiously, because from next question onwards, we will be quickly going through this. Subject to constraints. So now in this broad area, we will be adding constraints. How do you add constraints? Click on add. Okay, now you will get this like
Dialog box.
dialog box. Great, thank you. So now you'll get this dialog box, and here you can put the cell reference. Okay, now first we will be putting in the constraint which says that plants cannot supply more than their capacity. It means that the total supply that is there in these three cells, G16 to G18, should be less than or equal to what?
The total supply capacity.
Capacity, which is
That is
G5 to
G5 to
G7.
G7.
Okay, great. बहुत अच्छा.
Can you repeat this, please?
Okay. So idea is to put constraints. Okay, the first set of constraints are coming from here. Plants cannot supply more than their capacity, right?
Correct.
Now
Yeah.
it means that whatever is there in these cells, in these three cells.
Okay.
What is there in these three cells?
Supply capacity.
No, not capacity. What is being supplied? Capacity is here.
Okay.
यहाँ पे क्या है? Whatever
Shipment.
is coming out of whatever shipment is there. So sum of all these 4 cells is given over here. Similarly here, ऐसे करके, ठीक है? So what we are saying is that whatever we are supplying cannot be more than what is the capacity of these plants.
Okay.
So we have put G16 to G18 should be less than or equal to G5 to G7.
Okay.
Okay, let me add. Similarly for demand, okay, all these should be greater than or equal to, because as we have already discussed, we have to fulfill at least this much of units of demand. Okay, so that is why C19 to F19 should be greater than or equal to this. Okay.
Okay, sir.
Now click on OK. Make unconstrained variable non-negative. Choose simplex LP, or GRG non-linear will also work, but I choose simplex LP. Don't go in detail of what these things are. These are just engines. These are the algorithms that will be used in background. You don't need to worry about that. Click on solve. and you will get another dialog box saying that solver found an optimal solution. All constraints and optimality conditions are satisfied. Keep solver solutions, click on OK. Now you see, this is your solution. Okay. The total cost comes out to be 1000. I hope it is visible. Sorry for the bad choice of colors. And here you see it is saying that plant 1 should supply 15 units to DC1, 15 to DC2, 30 to DC3, and so on. Okay. Hello?
Okay, okay.
Yes,
Yes.
fine, sir. Fine.
Yes.
So this is how we have solved this problem. Okay. Uh, I have put this solver ka screenshot here. You can just cross check, verify, solve it at your end. You will find similar problems in many books. Majorly, there is a book by Sunil Chopra. So that book you can refer to for many such problems. Okay. Now let's move on to next question. What is the next question? A company has three plants again. Suppose demand for DC2 is now increased from 20 units to 50 units. Then what is the total transportation cost according to the new transportation plan? Okay. What we are saying is that demand has increased from 20 to 50 units. Earlier, demand at DC2 was 20 units. Now it is 50 units. Okay. Uh, it is asking that what is the total transportation cost. Now let me tell you that the total supply, what is the total supply that is possible?
130.
130. How much is your total demand?
160.
160. Now, can you fulfill that demand with this supply?
No.
No, 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 no.
No. So a simple logical answer would be that this is a non-feasible solution. Okay, solver cannot find a solution. So, but yeah, definitely you can go through the entire drill again, and your solver will give you such a dialog box. It will tell you that solver could not find a feasible solution. Okay. The question is same. Everything remains the same. Instead of 20 here, you put 50. Repeat the same process as we have discussed in question 3. Repeat the same thing, you will reach out to this solution. Basically, it is also something that is coming out of common sense, right? You cannot supply these 50 units to this without having more capacity here. Now let's move to question number 5. This is again like the process would be similar. It talks about suppose the management has decided to shut down plant 2 and increase the capacity of plant 1 and plant 3 to 70 units each. Earlier the capacity of plant 1 and 3 was 60 and
Sir,
40. Huh? Yes.
sir, sorry to interrupt. In the Excel solver, what were the solver results in the dialog box for the previous question, question 4?
Solver could not find a feasible solution.
Okay, okay, sir.
Okay. Now, again, this problem is very easy. You don't have to do anything new in this problem. I'll be quickly going through it so that we can move out to the real problem, which is the next one. Here, what you need to do instead of like change the supply capacities, put everything to be the same like what we have done in the previous question. You will find the entire solution here in this sheet. Okay. Now, the one thing that is of importance here is that total. I think total cost you can easily calculate by going through the same process. Uh, the thing that needs to be noticed here, is highlighted here, is that total supply here is now more than total demand. Okay. So in that case, plant 3 would be having 10 units of like underutilized capacity. So it can supply 70 units, but it will be supplying 60. Can anyone tell me why it is not supplying all the 70 units? or supplying more than what is there in like more than demand at any of these distribution center? Can anyone please tell me?
So nobody would like to have a stock in hand and increase the carrying cost.
Okay, that thing is there.
Nobody wants to keep inventory.
That thing is there definitely. No one would like to like have carrying cost, inventory cost, but that is not a solution here. That is not that is out of context in this problem. In context of this problem, if you supply any more unit, like let's say if instead of 60 it supplies 61 units, okay, that one unit will also cost something, right?
So transportation
The
cost.
transport cost will increase.
So the idea is to minimize the transportation cost. So the solver will supply only the units that are demanded, not even not one more than that. Okay. I hope this is clear.
Yes.
Again, let's quickly go through the next question. Next question is, suppose due to a network disruption, plant 3 cannot supply to DC4. Now, what will be the total transportation cost? Okay. Now, this question, there are many ways to solve this question. One can be that जहां पे हमने सारे को decision variable माना था, we will not consider this as a decision variable. Okay, that is one way to deal with it. Another way of dealing with it could be to write a cost, a very huge cost, let's say this much. Okay, so if we put this much cost, and even though this is our decision variable, तब भी जो हमारा solver होगा वो cost को avoid करने के लिए यहाँ पे zero ला देगा, because even if it supplies one unit, उसको इतना 10,000 देना पड़ेगा, right? It is trying to minimize the transportation cost.
Yeah.
So that is okay. So I have talked about two ways of dealing with it. First is to do not include it in your decision variable. Okay, so सारे decision variable में इसको आप you leave it. That is one way. Second way would be to increase the cost to a very high number. Okay, so जैसे आपने इसको 10,000 कर दिया, अभी 10,000 कर दिया, तो जब सॉल्वर सॉल्व करेगा ऑप्टिमल सोल्यूशन पे पहुंचने के लिए, तो वो तो कॉस्ट मिनिमाइज करने के लिए ट्राई करेगा, तो वो डेफिनेटली इस जगह पे मतलब DC4 का सप्लाई कभी भी प्लांट 3 से नहीं करेगा, क्योंकि वो किसी भी और प्लांट से करेगा तो उसको कॉस्ट कम आएगा, राइट?
राइट.
सो दैट इज व्हाई एक ये तरीका है इसको करने का. जो तरीका मैंने अपने सोल्यूशन में लिया है, जो मैंने सॉल्वर के थ्रू जो सेंड किया है, इट टॉक्स अबाउट एडिंग वन मोर कंस्ट्रेंट. ओके, अभी हम एक और कंस्ट्रेंट ऐड कर दें. एज प्लांट 3 कैन नॉट सप्लाई टू DC4, F18 शुड बी इक्वल टू 0. F18 मतलब दिस सेल शुड बी इक्वल टू 0. ठीक है, तो सॉल्वर में जहां पे हम ये सारे कंस्ट्रेंट ये दोनों ऐड किए थे, सिमिलरली वी हैव एडेड अनदर कंस्ट्रेंट. एज यू कैन सी हियर, ये आप देख रहे हो, F18 शुड बी इक्वल टू 0. अभी आप अगेन इफ यू विल सॉल्व इट, ओके, अरे दिस इज by clicking on something else I got this, but okay, so I hope you are so here you see it is supplying 0 units from plant 3 to DC4. I hope this much is clear. Now actually we are running out of time.
Avdesh, I have question on this. In this slide na,
yes,
for answer just go to the answer, assign last question 8, 9, 10.
Question 8, 9, 10. Yes.
Yeah. So here, if you go to the answer, the second last question, the route W2 to W1 is unused. I had selected this answer, but I got wrong. There it is mentioned.
Sorry, I've replied to your queries or someone else's query. It is because of like some like maybe while uploading we wrongly did it. But don't worry about that. I mailed it to the NPTEL team. We will get it changed. So you will get score for this mark. Mark for this question. Okay.
Okay. Thank you.
Okay. Now let me just quickly give you a brief about this question. This question is very like simple, but it will give you a very good like perspective of thinking about supply chains. Okay. Now here again, I'll just give you the brief. You have the solution. You can follow it. In case of any doubt, you can reach out to us. Okay. Now there are two factories, F1 and F2. Okay, and two warehouses, W1 and W2. Factories the capacity is given 40 and 50 and 40 units. Similarly, warehouse the capacity is 30 and 60 units. Okay. Now we have routes. You can see the arrows, right? Is it visible?
Yeah.
Okay. Okay. So alongside each every arrow, there is a cost defined. Okay, 900 per unit, or 200 per unit, or 800 per unit, and so on and so forth, right? Also, with some arrows, there are some units capacity is also given. For example, from F1 to W1, you cannot supply more than 30 units. Similarly, from F2 to W2, you cannot supply more than 40 units. Now, in this question, I want someone from you to tell me what is your decision variable, without especially someone who has not gone through the solution already.
I beg your pardon. What is this that you're asking?
I'm asking that tell me what would be a decision variable in this problem.
Number of units to be transported.
Transported through each route.
The routes to be taken.
The routes to be taken would not be a decision variable actually, because okay, what is your objective then?
Minimization of cost.
Minimization of cost. Minimization of cost. So definitely routes that are to be taken, but we are talking about number of products. 50 units are produced here, 40 units are produced here. So for every unit, you can identify the routes, right?
Right.
But the other way to like tell what is your decision variable would be to how much to supply through each route. Okay.
Yeah.
Okay, so this is what I've written in beam: x1, x2, x3, x4, x5, x6. So alongside each route, there will be some quantities that will be supplied, some units that will be supplied, right? So those units will be your decision variable. So we have correctly identified the decision variable. We have the cost for every route. Now, if we are supplying x1 units to this route, how much will be the cost of this route?
$900 per unit.
900 into x1. Okay.
Correct.
Right. So the first question was to how many decision variables are there in the problem. So I think there will be six. Not I think actually in this problem there are six decision variables. Okay. How much quantities to be supplied through each route? Great. I think. Sorry. I hope you understand. Now I put decision variables in green cells. Okay. Now your objective is to minimize the total cost. What? How will you get that total cost? It will be 900 into x1, 200 into x2, 1000 into x3, for 800 into x4, 200 into x5, and 300 into x6. Right.
Right.
So if you add everything, you will get the total cost. So you can see that this is the equation that I've written, formula. I hope it is visible and clear. In this problem, everything like identifying decision variable and objective function was comparatively easy. The catch here is to identify the constraints. Okay. So in any problem, whenever you talk about constraints, especially in supply chain, think about the capacities and demands. So production capacity of F1 and F2, this will be one constraint. Capacity of W1 and W2 would be the another constraint, right? Hello?
Yes.
Right.
Okay. So for
can you please repeat that again?
So
the capacity and demand thing.
So the production capacity of F1 and F2 is given, and that is one set of constraints. Okay. Hello.
Okay.
Similarly, the inventory holding capacity of warehouse 1 and warehouse 2 would be another constraint.
Okay.
Okay. And other important set of constraint will come from the constraint of the routes. That is, for example, यहाँ पे 40 units maximum capacity is there. 40 units can be supplied through this route. So that is one constraint. Similarly, 30 units can be supplied through this route. So this is another constraint. Okay. So now at F1, now I want you to pay attention to it. Now at F1, whatever is going out from F1 should be equal to whatever is being produced there, right?
Okay.
So X1 plus X2 should be equal to 50. Would it be wrong if I say that?
Yes. No, it is fine.
Okay.
Because
Similarly,
the supply
yes.
center cannot actually transport anything which he has more than that is produced.
So X1 plus X2 should be equal to 50. Okay. Similarly, here F2 pay up, if you look at it. So whatever is going out from F2, pay attention to it. Whatever is going out from F2 should be either produced there or coming from F1, right?
Okay.
So,
yep.
Or we can say that X2 plus 40 should be equal to X3 plus X4.
Fine. Okay.
Similarly, just pick another node, W1. Okay, W1 pe what can we say? That whatever is coming to W1 is either being stored at W1 or being forwarded to W2.
Okay.
And in terms of equation, how do we write that? Whatever is coming to W1, which is X1 plus X3 plus X5, should be equal to what is stored, that is 30, or forwarded, that is X6. So that is what I have written over here. X1 plus X3 plus X5 should be equal to 30 plus X6. Okay. Similarly for W2, like the same thing. Whatever is coming is either being stored or being transferred to W1 again. Now, again, look at it. Whatever is coming here is X4 plus X6 should be equal to 60 plus X5. X4 plus X6 should be equal to 60 plus X5. And sorry, I think I have, okay, 60 plus X5. Oh, I just noticed I have X5. Okay. So if I put it in the formula as well, so X3, X4 plus X6, X4 E10 plus X6, G10 minus 60 minus X5. Okay. And I hope the solution remains the same. Okay. So you see, like these are the things that we do, especially writing in writing constraints. So constraint identification is very much important, and we need to make sure that whatever we are writing is right. Okay. Now let's just put everything into solver, and we'll get the solution. I've already put everything into the solver. Okay. The idea is to okay. Let me just reset everything. Okay, reset all. What is your objective cell? This cell, right? B14, which is the total cost. Idea is to minimize by changing variable cells. What cells can we change? These cells we can change. Add. Okay. Now cell reference constraint this should be equal to 0. Add this should be equal to 0. Add this should be equal to 0. And this should be equal to 0. Also, we have two more constraints, which are x1 and x4. X1 cannot be more than 30. So x1 cannot be, should be less than or equal to 30. Another, x4 x4 क्या था? x4 should be less than or equal to 40. Okay. Now we have put everything into solver. Now let's click on solve. And let's see what happens. Okay. So the solution remains the same. The total transportation cost comes out to be 89,000. Thanks. Need to leave now. I also need to leave now. So okay. So I think with this, I'm about to close this session. I'll try to reschedule another session.
Kindly
And
drop
where
your
we
email ID so we can connect you.
Yeah,
so
please do share. Please do share this worksheet.
this worksheet is already shared with you.
Okay. Okay. Thank you.
Okay.
Your email ID also.
One more thing I want to ask is something you said whenever you have a problem with respect to constraints, you have to look at few things. Can you just repeat that?
So this is a directive kind of thing. You necessarily not always not find all the constraints and demands and supply, but most often you can check that the supply and the demand will give you most of the constraints. Okay, in terms of
Okay.
supply chain problems, network problems. Okay, constraints can be either like there can be other constraints as well. For example, in this question, sorry, in this question you see the capacity of routes is also given.
Okay.
Okay, but basic idea is to look for the demand and the supply capacity of all the nodes. Okay, email ID. Okay, yeah,
I
yeah.
think Adresh,
Yes, sir.
so they all have access to
Yes, sir.
that forum.
Yes, sir. Yes, sir.
So
Discussion
they,
forum.
they can anyway write
Uh,
their questions to that, because otherwise it will be difficult to track.
yes, sir. To track. Yes, sir. Definitely.
Yeah. So we can always give our personal emails, but I think it is better that all the queries are routed through the NPTEL email ID. That
Yes,
will
sir.
be easy to track. Otherwise, we may not be able to answer some of the questions. That is
Yes,
one
sir.
thing. And if there is a need, if we find that in the our forum, many students are requesting for one more session, we may plan one more session maybe next week.
Sure, sir.
And it will be better that in our forum we can also give a prompt that give their questions beforehand, so that directly we can start. Rather, we took 1 hour today for just giving introduction of the subject, which can be avoided then.
Yes, sir. In that case, I'll try to float a form so that, like, especially the questions can be
Yeah.
addressed there, and
Okay.
we'll be
So I
having those
think.
questions beforehand.
Mhm. I think with this we can now close. You can close the session. Is I need to end the meeting. You can stop sharing.
Okay. Just a second, sir. Yes, sir. Tell me.
Okay. So have a good time, all of you. And in case you have any question, doubt, please keep writing to us on the platform, and we may arrange more sessions for you. And it is always a pleasure to help you in resolving your queries.
Sure, sir. Thank
Sir.
you, sir. Thank you so much.
Okay. All the best.
Thank you, sir. Thank you.
Thank you.